Okay, we're going to be looking at torque, evaluating it using unit vector notation. We're given a rod that has an axis of rotation. We're going to be doing part A where the axis is through the point marked by O and it's perpendicular to the page. And once we finish this, you should be able to complete the part B of the problem where the axis is placed through the center of the rod. Okay, first of all, what is the definition of torque? And can you write it down in the cross product form? The net torque is equal to the net torques produced by each force at each lever arm from the point of rotation. So it's the sum of Ri crossed Fi. In this problem, where's the axis of rotation? Well, we've already talked about that. We're at point O. That is where our axis of rotation will be, at the end of the rod. Okay. Is there a torque from the 30 Newton force? Well, the force goes right through the point of rotation, or the axis of rotation. So there is no lever arm or no moment arm to produce a torque. So there is zero torque if the force goes through the point of rotation. Now, what is the 25 Newton force in unit vectors? And I'm going to denote the force from the 25 Newton force as F sub 25. Of course, I can write that as F sub 25, the force from 25 Newton force. We have my vertical or my horizontal component. In this case, it's the sine of 30 degrees, and you should be able to figure out why. And the vertical component is the 25 cosine 30 j hat. What is the lever arm? Well, the lever arm extends from O to point C, and that is R, vector R sub 25 equal to 2.0 I. And of course, we're taking I, X direction horizontal, Y direction vertical. What is now the torque? Since I know the F, the force, and the lever arm, I can calculate the torque. And we have that the torque is R sub 25 cross F sub 25, and we'll form the cross product. And you should be able to tell me why I do not have the factor 25 sine 30 I hat in that equation. And we have the total torque from that force. What is the 10 Newton force in unit vectors? You should be able to write it down. Pause the video and write it down. And of course, that is going to be 10 cosine 20 in the horizontal direction and a minus 10 sine 20 in the vertical direction. And that's the negative vertical direction. What is the lever arm? R10. And once again, that's in the X direction, so it's 4.0 I hat, since the force is at the 4 meters from the axis of rotation. What is the torque produced by this 10 Newton force? And of course, we have 4.0 I hat crossed with minus 10 sine 20 j hat. And once again, you should be able to figure out why I do not have the horizontal component in that calculation. And it's equal to minus 40 sine 20 k hat. Now, what is the total torque? Well, we've got two forces acting at two different points on the lever arm, both producing a torque. So we have to add both torques together. So we have torque sub 25, torque sub 10, we're going to add them. And after adding, we come out with total torque of 29.6 k-hat Newton meters. Now the k-hat refers to the direction of rotation. If it's a positive k, it's in the counterclockwise rotation. If it's a minus k, it's in the clockwise rotation. And this is governed by the right-hand rule, and you should be able to understand how the right-hand rule works in this case. End of problem.